In this video, we're going to introduce Dagster, which is a modern data orchestration tool for data engineers that are building data and AI platforms. Now, data engineering is all about taking data from various different sources, combining and transforming that data in some way, and then storing or manifesting the results somewhere else, for example, in a data warehouse. So the purpose of this is to get data in the right format for example, analysis and visualization, or perhaps to provide features to a machine learning model. Now, you can create what's called data pipelines, and these can represent your entire operation of getting data from various sources and loading that data into data warehouses and so on. So a pipeline could be a set of tasks, and they can run on a schedule or in response to some kind of trigger. And an orchestrator such as Dagster is a tool that can manage and coordinate these complex workflows and pipelines. And it does all this as Python code, so it's very nice, and we're going to dive in this video and have a look. Now, if you want to support the channel just before we start, check out the Ko-fi page we've got linked just below the video. And thanks very much to everyone that's supported the channel so far. And I'm going to add this video to this playlist on data engineering tools that I'm building up. And so far we've looked at DBT, DuckDB, and also some Snowflake videos, and we're going to add this one on Dagster. Now, I just want to start with a look at this diagram that kind of encapsulates what a pipeline is. And there's a workflow that's listed below here, and it's in the form of what's called a directed acyclic graph, or a DAG, and that is where the name Dagster comes from. So you can see this simple sequential graph below, and the trigger here is scheduled. It's at Friday at 7 AM, and then the next step in the task is to run a report. Then we download the results as a CSV, and then attach that to an email and send the email. So that's a set of tasks that can be represented in this kind of graph, and orchestration tools like Dagster and Airflow enable you to manage these very easily and get them in source control and so on. Now, what I'm going to do is open up VS Code, where we're going to write some code in this video. And I have a single file at the moment called assets.py, and we're going to use UV on the terminal at the bottom here to manage the Python environment. So let's create a virtual environment with the 𝗕_venv command. And notice that that creates the directory on the left-hand side, and then we're going to activate that with this command here. And we can now install requirements using the 𝗕v_pip interface. So it's going to be 𝗕v_pip install, and of course we're going to install Dagster. And I'm also going to install Dagster web server, and we're going to install the Polars module as well. We're going to use Polars in this video for some of the manipulation of the data. Let's execute that, and that's going to install those into the virtual environment. Now, if you're not familiar with UV, check out the previous video we did on that topic. It should be appearing on the screen now. And in assets.py, while that's installing, what we're going to do is go to the documentation for Dagster, and we're going to look at the definition of an asset. Now, Dagster calls itself an asset-centric orchestration tool, as opposed to Airflow, which is a task-centric orchestration tool. And an asset here refers to an object in persistent storage, and that could be a database table, a file, or a persisted machine learning model. The asset definition is a description in code of an asset that should exist and how to produce and update that asset. Now, there's a lot of terminology in data engineering. One of them is materialization or materializing. So when you materialize an asset, that's the act of running its function and saving the results to the persistent storage. Now, if you look at how to define an asset, we're going to go to this page here. The most common way to do that is using the Dagster.asset decorator. Now, if we scroll down to a definition here, you can see how to do this. Essentially, you import Dagster and then you decorate a Python function with the Dagster.asset decorator. So here we have a daily sales asset and we have a weekly sales asset downstream, and it's downstream because you can specify a dependency from one asset to another, and that's done with this dependencies argument to the decorator. Now, assets are central to Dagster. We're going to look at a very basic example now, and we'll move on to a more interesting one later in the video. Now, I'm going to define a function here, and it's going to be called hello, and I'm going to accept some context here, and that's going to be a particular type, and that type is an asset execution context. So in the body of the function, we can use this context here, and that has access to some logging methods such as logging.info, and we can log out hello to the terminal. Now, to make this a Dagster asset, all we need to do is decorate that with the Dagster.asset decorator. Now, once we've done that, we can essentially just copy this function, and I'm going to paste it below, and we're going to have a second function called world, and we can change what's being logged to world as well. But this time we're going to pass a parameter or an argument into the decorator, and we're going to specify that this asset has a dependency or a set of dependencies, and it's going to be a list here, and we can pass the above function called hello. So what that means is that the hello function is upstream in data engineering terminology from this world asset. So this world asset here depends on the hello asset, which means that the hello asset needs to execute and complete before we run this world asset. So the world asset is downstream from the above function. Now, the final thing we need to do here is define our Dagster definitions. You can do that using a Dagster definitions object. So let's do that just now. We instantiate a definitions object, and we're going to pass the assets in here, and it's going to be the hello function and also the world function. Both of those are assets, and we pass them in. Now I'm going to very quickly go to a concepts page for Dagster, and you can learn more about important concepts like assets and definitions, graphs, jobs, and so on. If we go to the definitions concept here, you can see that all of these, such as assets, IO managers, jobs, and so on, all point into a definitions object. So if we scroll down here, definitions is a top-level construct that contains references to all of the objects of a Dagster project, such as assets, jobs, and so on. And we also have scheduled definitions that we're going to look at later in the video for actually running tasks on a particular schedule or periodically. Now, only objects that are included in the definitions are going to be deployed and visible in the Dagster UI. We're going to look at the Dagster UI in a second. So what you can do is essentially pass your definitions into this definitions object to make them available on that Dagster UI. Now let's actually see this and run the Dagster UI. What we can do is clear the terminal, and we're in this directory with the assets.py, and we're going to run dagster dev, which is a command on the Dagster CLI, and we can point that to the file of assets.py. So let's try running this command. Now you can see in the terminal it's launching some Dagster services, and it started the Dagster web server on localhost port 3000. So if we go to the browser on localhost 3000, you can see this page here under assets. And in this graph here, we have the two assets that we defined, and we can see that directed dependency between the two of them. So again, you have a directed acyclic graph. You define these assets, and one asset can depend on many other assets and then can point downstream into other assets. And you can build up this directed acyclic graph like that. Now notice as well, it says never materialized. So we're going to materialize both of these assets by clicking this button at the top here. Now before we move on, another bit of terminology here. This is referred to as the lineage of our assets. So you can see that at the top we have a lineage, but we can flick to a list view as well. I think the lineage looks nicer. And now we're going to click the materialize all button, and that's going to actually run our functions, run our assets under the hood. And you can see the UI has updated here. It's materializing this first asset. So this is essentially manually starting the data pipeline. And you can see that the first asset is materialized, and it's now running the second one, and that one has also finished. Now what's that actually done? If we open up VS Code, we're getting these debug logs, but if we scroll up here, we have this info log, and you can see this output here. I think that's coming directly from this statement. But the important thing is these functions are being ran, and one of them is dependent on the other, and they run in the correct order. Now when we actually materialize those assets, this is known as a run. And if we go to the top here and click runs, you can see we have a list here containing all of the runs that we've performed. Currently we only have this one here, but we can click through to that to get more information, and I think this looks better than the command line. So you can view the logs here, and that's going to be helpful to diagnose any issues as well. So what I want to do now is create a more interesting example, and that's going to fetch some data from the web and write it to the local file system, and then store that data into a DuckDB database. So what I want to do is go to the command line here, and I'm going to stop this Dagster development server, and we can clear the terminal. Now there's another command called Dagster project scaffold, and we're going to give this project a name of car_data. Now the data we're going to work with is going to be some car data, but when we run this, it's going to create a Dagster project, and it's going to be in that directory of car data, as you can see here. And there's a directory for tests if you want to write those, and then a directory where you can define your assets, and a definitions.py as well. Now it's a best practice not to have everything in one file, so what you can do is define your assets inside assets.py, and similarly you can define all kinds of other objects in Dagster in their own modules, and then import them in and use them in the definitions. Now on the command line, I want to cd into this new project folder, and we're going to take a look at the data that we're going to download. Now this is a dataset from Microsoft Azure. I'll leave a link to that below the video, and you can see it's a CSV dataset consisting of data about cars. Now if we go to the raw dataset, what we're going to do is copy the link in the URL here, and let's go back to the assets.py file, and we're going to paste in a variable here called CSV URL, and that points to that link that we copied from the browser. Now I'm also going to define a path to save this CSV to the local file system inside a data directory. So inside this project folder, let's create a data directory. And in a real pipeline, you might want to have stuff like this extracted out into environment files. And at the top, we're going to bring in a couple of imports. So we're going to import Dagster as DG, and we're also going to import Polars as PL. Now let's define our Dagster asset, again using that Dagster.asset decorator. And the asset function that we're going to define here, I'm going to paste in some code. It's going to be called car data file, and it'll take that context from Dagster as an argument. Let's use that context to log out some info. We're going to say downloading CSV file, and then we'll create a Polars data frame. And what we're going to call here is the polars.readCSV method. Now the source is the required parameter to read CSV, and we can actually provide a web URL here. So we're going to paste in the CSV URL, and that's then going to download that CSV data and create a Polars data frame from the data. So once we have the data frame, what we're going to do is we're going to transform some of that data a little bit. And if we go back to our link here and go back to this data, I want to transform this normalized losses column. So basically I want to cast the value here to a floating point number. And if we scroll to the right hand side, there's also a price column, and that contains these question marks as well. I want to replace that with a floating point number or with 0 by default. So in order to create a transformation with this data frame, what we can do is use the _columns method in Polars. And then we can pass a list of the different things we want to do here. So this is going to add columns to the data frame, the _columns method, but we can also overwrite existing columns. So we'll create a column here with the pl.call, and then we can pass the column name in. So it's going to be normalized losses. And what we can do here is cast that to a data type. And we're going to use polars.float64. And to make this work, we're going to pass strict equals false. So when we set strict to false, invalid casts are going to produce null values. Now we're going to do the exact same for the price column, so let's copy this to the line below, and we're going to update the name of the column to price. And the final part of this asset is going to materialize the CSV data to the local file system inside this data directory. So to do that, we can use the data frame's write_CSV method. That's a Polars method on this data frame. And this time we're going to pass in the path that we defined on line 5, so let's paste that in there. And hopefully we're going to see that that's going to write that file out to the file system inside the data directory. Now I'm going to expand the terminal and let's clear what we have here. And we're going to run Dagster dev. And that's going to start up that Dagster web server with the user interface that we can then view and start materializing these assets. At the moment we only have one. We're going to add another one later in the video. And when the UI loads, you can see we have this single asset in the asset lineage. And notice this text here downloads the CSV directly with Polars. That is coming directly from the doc string that we define in this function. So that maps nicely over to the Dagster UI. Let's now click materialize in order to actually run this function. So you can see that's materializing now, and what we're doing is building up a Dagster pipeline here. And we're using Polars at the moment for easy reading and writing to and from a CSV file. Now once this is materialized, as you can see here, if we go to the local file system and go to the data directory, you can see we have a file here for the car prices. Now if you look at this, I'm not going to look at all of this data here, but basically it's removed those question marks from the second column. So instead of a random question mark, we now have just an empty value, and you can see some of the rows do have a value for that column. But importantly, we now have our materialized CSV file on the local file system. And at this point, there's a lot of things we could do. We've written the CSV locally. We don't need to fetch it over the network. We could then clean that data further, or we could load the cleaned data into an SQL database or a data warehouse. Or we could produce some analysis on the data, or produce an API that exposes that data to Power BI or Tableau or something like that. Lots of different options. You could send an email with the CSV file. All of that is possible in Dagster because Dagster is the orchestrator of these events, and you can define these dependencies between different tasks. Now let's say that we want to create a DuckDB database with a single table that contains aggregated results from the CSV data. And let's say we want the average price per make. So we have this price column here, and each car has a make as well. So if we go to the make column, you can see some of the cars here. What we want to do essentially is group by this make column and then calculate the average price per make. So in order to do that, I'm going to go back to VS Code, and we're going to define a couple of extra global variables here. So one is going to be the DuckDB path. This is going to be a path to our DuckDB database on the file system, and also a table name. So we're going to create an aggregated table here called average price per brand. And at the top, I'm going to import DuckDB as well. And we're going to need to install that. So let's go to the file system. I'm going to stop the Dagster server here. And what we're going to run here is uvpip install, and we're going to install DuckDB. Once that's installed, what we're going to do is define our second asset that's going to be downstream of this asset. So let's copy this, and we're going to define a second function in assets.py. And let's rename this to average price table. And we're going to pass a dependency into the dagster.asset decorator. So it's the deps argument, and we're going to set that to a list containing that single function that we defined above called car data file. Now this makes sense because we are going to store the file on the file system, and only after we've done that do we want to then take that data and save it to the database. So the database step is the second step in this pipeline after we fetch the raw data from the web. And we can add a doc string here so that that appears in the Dagster UI. This is going to compute the average car price per brand and store it in DuckDB. So again, let's log some information. And we're going to need to read the CSV again. So we're going to call the polars.readCSV method. And this time, instead of reading it from the CSV URL, we can read it from the path on the file system. So let's paste that path into this function. And what I'm going to do is simply drop the nulls from the price column. So we can call df.drop nulls. That's another method on Polars data frames. And we can pass a list of the columns where we want to drop the null values from. For us, we want to drop them from the price column. So what's going to happen here is that all rows that contain a null price are going to be dropped from the dataset. That might be what you want, it might not be. You can do other types of things as well, but we're just going to keep it simple for this video. What we then want to do is compute the average price per brand. So let's create a new data frame here called average price data frame. And we're going to take the data frame and we're going to call the group by method. And we're going to group by that make column that we saw on the online data. Once we've performed the grouping, we can then call the .ag function to do an aggregation. And we're going to aggregate over a column here. It's going to be the price column. And then the aggregation we want to perform is the mean. So we're going to get the mean or the average for each group that we've found. And then we can alias the result using the .alias function. And let's alias that to average price. And we're then going to store that in the DuckDB database. So what we're going to do is convert the data to a list of tuples, and that's the expected format for DuckDB. So I'm going to copy this line of code. So we're going to create a variable called data, and we're going to iterate over the results of this expression here. So we take the average price, which contains the make and the average price for each make, and we convert that to dictionaries. And then for each row, we're going to take the make and the average price and store that in a tuple. Once we have the data in this format, we can open a context manager, and we're going to use the duckdb.connect method. So duckdb.connect, and then we can pass that duckdb path. That's the one that we defined just at the top here. And this is going to point to a location on the local file system. So we're opening that in the context manager, and we'll call that connection. And then we can execute some statements here. So for example, drop table if exists, and then we'll pass the table name. Again, that name is defined up here. And we're going to reuse that table name throughout this query, which is why we've extracted it to a variable. And we can then recreate that table. Again, it's going to be connection.execute. And this time we're creating this table with the given columns. Another way you might want to do this is just to truncate the table with the existing values before you write the new ones. And then finally, we're going to insert the data. So I'm going to paste one more statement here. We're going to call the execute_many method. And we're going to insert into that table name the values that we've got in the data that we prepared on line 36. So that data, every single element of that is a tuple containing the make and the average price. We're inserting all of that into those two columns in the table. And this is the syntax for doing that with the placeholders. Once we've done this, what we can do is save this, and we're going to restart the Dagster development server. So Dagster dev on the command line. And while that's starting up, I want to go to definitions.py. You might be wondering how this is working, because we didn't explicitly add any definitions to that definitions object we saw earlier in the video. Dagster has some utilities such as load assets from modules, and you can see we're passing the assets into that have been loaded from the car data project. So that's automatically picking up any new assets that we define. So what I'm going to do now is go to the Dagster UI, and once that loads, you can see we now have this directed dependency between the car data file and the average price table assets. So let's click materialize all, and hopefully what's going to happen is it's going to create that table in the DuckDB database containing that aggregated data with the average price per car make. And once that's completed, you can see these are both materialized. If we go back to VS Code, let's have a look at the data directory, and you can see we have a DuckDB file on the file system. And what I'm going to do to verify that this is working is open the command line and run the Python interpreter. So let's start a new terminal here, and I've activated that virtual environment. Let's run Python here to start the interpreter. And at the top here, we can import DuckDB, and we can define that connection to our database using duckdb.connect. And finally, just to verify that that table exists, what we can do is execute a method here. So we're selecting all from the average price per brand table, and then we call the fetchAll method to get those results into the Python memory. So let's execute that, and you can see we have this data here for Alfa Romeo. The average price apparently is this number here. For Dodge, it's this number, and so on. So we've calculated the average prices from that data that we grabbed from the Azure GitHub. And we now have this table in the DuckDB database, and you can imagine that feeding into some kind of visualization or business intelligence platform to visualize those outputs. Now this is just the tip of the iceberg. If we look at these assets, you could also send an email with the CSV data or with the aggregated data. You could send a message to a Slack channel or a Discord channel, or you could trigger some kind of other task somewhere else externally. Lots of options, and Dagster is the orchestrator for that. It's maybe a little bit difficult to see with just this simple example, but if you have complex workflows, this can be extremely useful. Now I want to show one final thing very quickly, and that's scheduling tasks. So I'm back on this concepts page, and we're going to go to the schedule section. Now what you define is a schedule definition, and it's a way to automate jobs or assets to occur on a specified interval. Now Dagster is an orchestrator, and it should be able to trigger these tasks in a variety of ways, not just manually through the Dagster UI. So the schedule definition is one way to do that if you need to run particular tasks at given times or periods. Now I want to go back to the Dagster Essentials course, and we're going to look at this page here on what are schedules. Now it's pretty easy to imagine what a schedule is, but I'm going to scroll down to Anatomy of a Schedule, this section here. So a schedule definition has different components. One is a job and the other is a cron expression. So jobs are another concept in Dagster. We're going to take a look at that now. So when you work with large asset graphs, you don't always want to materialize all of your assets on every run. An example of that might be from our code here. We might download the file once every week, but let's assume the file doesn't change too often, but we may have other parts of the graph that execute more frequently that don't depend on that file. That's just one example that I've just come up with on the spot, but there are better ones out there. So jobs are a Dagster utility to take a slice of the asset graph and focus specifically on running materializations of those assets. So not the whole graph, but a specific subset of the assets. What I'm going to do in VS Code is create a new file in this directory, and we're going to call this jobs.py. And here we're going to define the jobs. Now if we go back to the documentation, to select the assets you want to include in the job, there's an asset selection class that you can use from Dagster. And that class lets you look up and reference assets across your code location. So you can get every single asset using the .all method, or you can get a subset using this .assets method. So in the jobs.py file, they have this code that's defined here. The asset selection is called trips by week, and what they do is they select a given set of assets, and this time it's just this one here called trips by week. And the reason you might want to isolate that is because you don't want to run the rest of the pipeline. This particular asset you might want to run on a different schedule, for example. So you can select that asset using this method here, and then you create a job. So here we have a trip update job, and we use the dagster.defineAssetJob method. So the job has a name and it has a selection. And you can see this logic for the selection. We basically take all the assets in the project and we subtract that single asset called trips by week. So it's going to run all of the assets except trips by week. Once you've done that in the jobs.py file, you then define the schedule. So we'll come to that in a second, but you can use the cron syntax if you're familiar with that. Let's go back to VS Code, and I'm going to paste some code in here. So we're going to import Dagster, and we're going to use that defineAssetJob method. And we'll give this one a name of car price job and a selection. Let's just select all of the assets using that asset selection.all. So with the job in place to run these assets, we can now define the schedule. So what I'm going to do in car data in this project is define or create a new file here called schedule.py. And we're going to create a schedule definition. Now let's go back to the documentation. Here we have a page on creating a schedule. What we do is we create a schedule definition class and we pass the job into that as well as the cron schedule. So that's simple enough. Let's go back to VS Code and paste some more code in here. So we're importing Dagster and we're importing that car price job that we defined here in jobs.py. So we bring that into the schedule module, and then we create a Dagster schedule definition and we point the job at that car price job. And for simplicity, the cron schedule is going to be every single minute so that we can see that in this video. Of course, you can make this whatever you want. For example, run this report at midnight every day, or once a week, or once a month, and so on. Now the final thing to do is add these to our definitions. So at the top here, we're importing the assets. I'm going to paste a couple of more imports. We're going to import the job and the schedule. And underneath the all assets variable, I'm going to create another one called all jobs that's going to contain a list with that single car price job, and all schedules with a list containing the car price schedule. And all we need to do at the bottom is add these to our definitions object. So I'm going to paste them in here just now. We add the jobs and the schedules, and that makes them available on the Dagster UI. It tells Dagster about these. And what we can do now is go back to the terminal. I'm going to stop the existing server and let's rerun the Dagster dev command. Now, when you run Dagster dev, it also spins up the Dagster daemon, and that's a long-running process that does things like check the time to see if a schedule should be run, or if a sensor should be ticked, and that's something we'll cover more in a future video if there's any interest below the video. Once the server is running, we can go back to the browser, and again we can see the lineage here, and if we go to the top we have a jobs section here, and we can see that car price job that we created. So that's now on the nav bar, and we also have this automation section as well. So here you can see the scheduled job, and you can see it's scheduled to run every single minute. And the target refers to the job, which is a subset of the assets in your pipeline. Now we can turn this on, and it's going to start running that task or running that job every single minute. And we can go to the runs tab at the top here, and you can see here that the job is starting. And that job was launched by this. That was the schedule that we created. So we have a tick here, and we also get the time for the next tick. In this case, it's 1 minute later. So the Dagster daemon that's running in the background will take care of running these jobs at the scheduled time. So if we go back to the run section, you can see the second job 1 minute later. That's starting up now, and that is also running because of this scheduler. So now we can run tasks on a schedule or periodically, for example, every second day at midnight. In a real pipeline, you wouldn't necessarily be running jobs every single minute. We're doing it here just for demonstration purposes so we can actually see the results in the Dagster UI. Now, one thing that could happen, for example, and I just want to cover this just to show what could be possible using Dagster, we could produce a CSV file very similar to what we've done here, and then send that data to object storage, for example, in Amazon S3 bucket. And then once that's in the bucket, what you could also do, and I'm going to go back to the Dagster documentation and go to the concepts section for this. If we click sensor right at the bottom here, we're going to find out what this sensor is in Dagster. Now this is a way to trigger jobs or assets when an event occurs. And that event could be something like a file being uploaded or a push notification. So this allows you to perform things in an event-driven manner. And that flexibility is why Dagster is so good. It can orchestrate things when events occur, and it can also orchestrate things on a schedule periodically. And of course you can do it manually through the Dagster UI as well. Now if you're familiar with Amazon Lambda functions, these are similar to triggers in a way. So when you upload a file to an S3 bucket, you can then trigger a Lambda function to execute when that new object appears in the bucket. The idea of a sensor in Dagster is fairly similar. So that's a lot for this video. We've shown the basics of Dagster, and we've created some simple code that's going to grab a CSV file from GitHub. So if we go back here, we can see we have this asset here. It's going to download that and store it on the local file system. And then we have a second asset that depends on that initial asset that's going to read the CSV file that we got. And then it's going to compute an average, so it's going to compute an aggregation over that data and store that inside a database table in DuckDB. There's many different ways we could approach this. We could use 𝗬𝗚, for example, but that's going to be all for this video. There's so much more that we could do, and there's much more advanced assets that we could show. We could also look at partitions and resources and other concepts in Dagster. And we could look at integration with a tool like DBT, for example. If you're interested in any of that, let me know in the comments. And finally, if you found the content useful and you want to support this channel, check out the Ko-fi page that we've got just below the video. Thank you very much to everyone that's contributed to that. And don't forget to subscribe if you haven't already done so. Thanks again, and we'll see you in the next video.